Okay, so our last problem in 7.5, we're looking at now a sphere. So our radius here will be 10 feet. We're going to fill it to the halfway point with oil. And for simplicity's sake, this oil happens to weigh a nice, neat, pretty round 60 pounds per cubic feet. So we're going to put a pump at the top. And we're going to use the pump to empty the tank. And we're going to find the work that the pump performs. Okay, so now for another one of my beautiful, beautiful sketches here. So for simplicity's sake, we're going to sort of start with a circle of radius 10. And we're going to have the bottom of that circle on the origin. So up to the halfway point, we fill it. Halfway point, so that would be 10 feet up. And again, we'll draw a nice little representative rectangle. The three-dimensional version would then turn into basically a representative disk. So our height here would be y, our thickness delta y, and the height that the oil will travel from this representative piece would be then, 20 minus y. So our circle of radius 10, concentrate on the black part for the just sort of flat circle. Center of our circle would be at 0, 10. So x minus 0 squared plus y minus 10 squared is equal to radius squared. So then x squared is 100 minus y minus 10 quantity squared. We can do a little simplifying there. 100 minus the quantity y squared minus 20y plus 100. And a little distributing, so x squared is opposite of y squared plus 20y. We have 100 and then minus 100. Those will knock each other out. Okay, so then our delta force, change in force, is the weight. So change in force, 60 pounds per cubic foot. Times the number of cubic feet that we have. X squared times delta y. So where this pi x squared is coming in, If we look at our sort of representative little circle here, the area of that disk at the top is pi r squared. Our radius is from 0 to x, or just x, and then times the height of the right circular cylinder. So nice flat, flattened down soup can, so to speak. We can do a little bit of substitution as well. So we can also say delta F is 60 pi by opposite y squared plus 20y times delta y. So now instead of two different variables floating around, they're both written in terms of y. So then the change in the amount of work done is change in the force times the distance. So change in work, change in force, we have that already set up here. So 60 pi by minus y squared plus 20y, excuse me, times dy, or delta y. And our distance, how far the oil is traveling, it's going up 20 minus y. So then a little bit of multiplying out, change in work. I'll hang on to that 60 pi at the front. We'll put our delta y or dy at the back, and we'll go ahead and multiply this stuff out. So opposite y squared times opposite y is y cubed. Opposite y squared by 20 is minus 20y squared. 20y by 20 plus 400y, and 20y by opposite of y minus 20y squared. So we have change in work, 60 pi by, we've got just a couple like terms there to play with, y cubed minus 40y squared plus 400 times y times delta y. So when we do the amount of work, we're just going to integrate this, and we're going to be working with y's that are going from where the oil is, y equals 0 to y equals 10. So let me go ahead and set that up on the next page. So the amount of work performed, integral from y is 0 to y is 10 of 60 pi times y cubed minus 40y squared plus 400y times dy. So our work performed, we can just hang on to the 60 pi, sort of along for the ride at the moment. Antiderivative of y to the third, y to the fourth. To avoid having a 4 when I differentiate this, we'll put a 1/4 out front. Antiderivative of y squared is y cubed. To avoid the 3 out there, I'll need a 3 at the bottom, so we have negative 40, that was already there, and a 3 downstairs. So again, just picture differentiating this. 3 by a third drops out, negative 40 stays there, y to the third is down to y to the second when we differentiate. Y to the first is now y squared, so we'll need a 200. 2 by 200 gets us back to the 400, and we're evaluating that again between 0 and 10. So we end up at 60 pi by 27,500 over 3. A little canceling there. So 550,000 pi foot-pounds of work performed. if you want the decimal approximation without the pi in there, let's see, 1,727,875 and 959 thousandths foot-pounds. So that is the amount of work to get the oil out of the barrel with the pump put at the top of the barrel, top center of the barrel. Sort of check to see if this is reasonable. First, we'll take a look at the volume of fuel that we're looking at. Volume of a sphere, 4/3 pi r cubed. Our radius is 10. And remember, we only filled it halfway then. So our volume, let's see, nice little bit of cancel out there. 2 upstairs there. It's 10 cubed is 1,000, so 2,000 pi over 3 cubic feet of oil. And so then the weight of the oil, 2,000 pi over 3, that's in cubic feet. And we're told at the beginning of the problem the oil weighs 60 pounds per cubic foot. So we can divide our cubic feet, and that'll give us our weight. Another nice little bit of canceling there. So the amount of weight that we have in there, 40,000 pi pounds, or approximately 125,663.7061 pounds. So if that's the weight, and we want to, the weight, remember, is a force, so we want to lift it 10 feet. Again, the oil at the top is only going 10 feet. The oil at the bottom is going up 20 feet. So this is going to be a little bit of a lower bound on an estimate. So a distance of 10 feet would put the work at, we'll just multiply that by 10 then, 1,256,637.061 foot-pounds of work. And that is reasonable. Again, we said it would be sort of a lower bound since only the oil at the top is going the minimum of 10 feet. Some of the oil is going up 20 feet. So our answer is pretty reasonable. That's a good estimate on it. Okay, so now as far as problems to try out from that section, this was section 7.5, 1 through 11, the odds, 17 to 23 odds as well. And number 21, I want to leave you with a hint as well. So the radius is dependent where you are. So if you make a little triangle, you'll put 0, 0 down here. And this was 6, 0 up. 0, 6, my apologies, 0, 6 up here, and 4, 6 over here. You want then the equation of this line. And another hint on number 23. Distance is y, not 6 minus y. Okay, so that should get you started on section 7.5. That should give you plenty of problems. If you have any questions, please get in touch and stay safe out there.